Variable speed ventilation VFan presentation, an old concept made new again. We're going to be talking about it today for about 45 minutes. I'm Sean Francie. I'm the general manager here at Val Products. And today we're going to be hearing from Mr. Trey Martin, our territory manager covering poultry out in the Midwest, and also Mr. Ben Carvel, our application engineering manager, who covers a lot of things to do with the background of how we quote and how we handle and how we support and serve all the products that we make here and put out to the field. We're planning on about 45 minutes for this session, and we want to respect your time this morning. If you would, during the presentation, it's helpful if everyone makes sure that they're on mute. If you do have questions during the presentation, down at the bottom of the screen, there's a chat function. Feel free to type your questions in there. Those will get sent in to the host of the meeting, who will put them all together, and then we'll have a Q&A session where we'll go through any submitted questions at the end and kind of open it up at that point. We'll also be hearing towards the end of it, right before the Q&A, from Mr. Doug Murkey, who is one of our engineers out in Coldwater at our training facility, where we have a VFan installed there that we'll actually get to physically walk through and see some of the things that way. So with that, I'm going to turn it over.
Thank you, Sean. Good morning, everyone. Hope y'all are doing well today. First, I just want to say thank you for taking time out of your busy schedules to join us this morning for our webinar. Today, we're going to be discussing variable speed ventilation. We're going to look at the different attributes, some past versus present features of that type of ventilation. We're also going to take a look at our new Valco VFan line that has been released this year. Then we're also going to look at some different scenarios and different applications to see how this may fit into your organization. So kind of take a look at the history part of it first. Variable speed ventilation first hit the poultry industry about 5 to 6 years ago. Whenever this first was introduced, it was mainly your smaller type minimum ventilation fans that were used for variable speed. That's typically your 36-inch, your 24-inch fan. Tunnel ventilation or tunnel variable speed fans didn't hit the market or didn't hit the poultry industry until about 2 years ago. And just to kind of let you know, Europe has been using variable speed as a type of ventilation for about 10 plus years now, and they've seen some great results from an energy efficiency standpoint, which is one of the reasons why this got brought into the States. Now, back 5 years ago or so, the variable frequency drive had to be mounted inside of an airtight cabinet or box if it was going to be kept inside the environment where the birds or hogs were, just because that control at that point in time was not rated for that type of environment. We also saw some issues with bearing life, so that obviously increased your maintenance and repair cost. And then also, with it being new to the market, it was very expensive, as there weren't very many manufacturers who were actually building them at that point in time. Now, to kind of look at more of your current type models or current type variable speed options, which is what our Valco VFan is. We have a better variable frequency drive available here on the market nowadays. And what I mean by that is that as far as washing the fan goes in between flocks, etc., you don't want to have to worry about water splashing up on the VFD control, which in this case, one that we use is water resistant, so therefore you don't have to worry about that. Now, you can't fully submerge it into water, but if you get some water on it, it'll still operate just fine. And also, you don't have to worry about putting it inside of an airtight box, because the actual unit itself is protected from dust. So therefore, you're able to keep it inside the environment. Bearings are lasting a lot longer nowadays versus what they were back 5 years ago. So you obviously don't have, that's going to reduce your maintenance and repair costs right there. As far as the overall cost of the fan itself, since it is being produced from a more mass standpoint, and what I mean by that is more manufacturers are producing them nowadays, the cost has come down considerably versus what it was 5 or 6 years ago. And as time has gone by, our motors have gotten more efficient, so that's also plays a role into this Valco VFan being very, very efficient as far as just from an energy standpoint. Now, to kind of touch base or kind of talk about the motor that we use in our VFan, it's a PMAC motor, or a permanent magnet AC motor. And just what that is that the magnets come already embedded or already put inside the rotor of the motor. So what that gives you is whenever the fan first kicks on, it gives you a lot more quick, efficient response. So that way you don't waste the electricity like was wasted before in your older style motors, because they had to generate a magnetic field. So you don't have that wastage there. You're obviously able to pull more CFMs with one fan using the same size motor. So in some cases, it could actually mean that you could use fewer fans within your application. As I mentioned, the motor that we use is an AC motor, but in some cases, you may see DC motors within some applications. Now, I mentioned our Valco VFan line that we released this year. I just kind of wanted to run through some attributes or different options with that. We have our 50 and 54-inch tunnel fan. We just recently added our 36-inch sidewall fan. Now, all these fans contain the new attributes that I just mentioned in the previous slide, as far as from a variable speed ventilation standpoint. And we also have several options. You know, maybe you want a galvanized fan housing or a fiberglass fan housing. Maybe you want a different style blade. Maybe you need 3-phase. Maybe you would prefer single phase. You know, whatever your options are, or whatever scenario you need, we pretty much got you covered. After you view this webinar today, if you are interested in finding out more about the Valco VFan, I would encourage you to reach out to your local Valco distributor or local sales rep to see which fan would fit your application best. So why choose a VFan, or why choose variable speed ventilation versus your typical on-off fan type ventilation? So for starters, the first thing I think about is, with this being a direct drive fan, you can already have less maintenance and repair cost, because you don't have to change out belts every year. You don't have to replace tensioners as they wear out, and you also don't have the variance degrees like you do on your on-off style fans. And in some cases, you may even be able to save on electricity, because you can actually run fewer power cables back to, say your controllers in your half house, a control room, running fewer power cables from there back to where the fans are in the back of the house. So that would be on a case-by-case basis, but that could potentially be some savings. Also, you could actually have fewer fans overall in the house, depending on what your application is. And Ben's going to touch on this here in a few minutes, but just a quick example, let's say that you have two 36-inch regular on-off fans there in your brood chamber in a broiler house. Well, you could replace those two 36s with one of our 50-inch fans or with one of our 54-inch VFans, and that you could actually use that and just gradually move up your speed or gradually lower your speed of the fan with the VFD control, depending on what the house temperature is. So you save on maintenance costs, because you have one less fan in that scenario, and you can also save on your, just because that this fan is more energy efficient than your typical on-off fan. And also, just to add to that from an energy efficiency standpoint, in some areas you could actually get grants or rebates for installing more energy efficient fans, especially if you're in a retro type situation. So you got fans that are 10+ years old, and they're, in some areas you could be able to be eligible to receive some grant money, whether it be from your local energy provider or whether it be from a federal standpoint there with the USDA. So I would certainly encourage you to reach out and to take a look at that. And also with the variable speed or our Valco VFan, you do get more even air temperature from side to side, front to back within the house. So as far as if you were to plot those points on a line graph, as far as your temperature points, you don't have the peaks and valleys as you do with your regular on-off fans with our Valco VFan. Now, just a couple of quick points to kind of discuss as far as what sets our VFan out from the competition. Our variable frequency drive controller actually comes pre-wired and pre-programmed to the motor. As you can see in this picture in this slide here, that blue and black box, that's the VFD control. It comes pre-wired, pre-mounted to the fan housing itself. And so what that allows you to do is to not have to find a place to put it right there next to the fan, not have to worry about taking it all the way back to your control room area. And also with it being mounted there on the fan, it's going to have increased airflow as the air exits the house through the fan. And so it's going to allow the VFD control to stay cooler. Now on this slide here, we've talked about the energy efficiency advantages of our Valco VFan and just variable speed fans in general. But I wanted to point out a couple of things here. This is two of our 54-inch options. Best Labs ran these figures for us last year, towards the end of last year. So I wanted to point out the full speed and half speed for both of these different options or both of these different models. As you can see on the full speed, we're bumping 35,000 CFMs at a 0.05 static pressure. So you're going to get a lot of air movement. But on the flip side of that, you run this fan at half speed down there at the bottom there. We're averaging about 60 CFMs per watt. So not only do you get the airflow, but you also get the great energy efficiency whenever you do run it at your slower speeds. So with that being said, Ben Carvel is going to now talk about some different scenarios and different applications. So Ben, the floor is yours, man.
Thanks, Trey. Good morning, everyone. Thanks for joining us. As the applications portion of the presentation on VFans, I was going to start by discuss a little bit more in depth some of the aspects of the performance and where our variable speed fans really shine. So in these charts on the variable speed fans, what I have shown here is two standard 36-inch fans plotted and two 36-inch variable speed fans plotted. So we're custom looking at airflow versus static pressure charts for sizing our ventilation. So what we're looking at here on the left-hand chart, the blue, the orange, the gray, and the yellow are different frequencies, different speeds for our variable speed fan. And then the black dashed line is a standard on-off fan. So as Trey was commenting on these fans and the efficiency of the motor and the power output, you can see at the top end, the blue line is above what a standard 36-inch fan would be. And if you go over to the right-hand side, we're looking at efficiency in CFM per watt over static pressure in inches of water column. So you can see if you follow that same blue line, that even at the highest end of output, that blue line is above the dashed black line, which means even at that higher performance, it still performs at a higher efficiency, which is a good thing. The dashed line back on the left, the dashed red rectangle, I have sketched on there as a common minimum ventilation zone. So typically in minimum ventilation, we're at 0.05 to 0.1 inches of water column or somewhere in that range. And if you go vertical, we're at around 3,000 CFM or something at the low horizontal line, up to about 25,000 CFM. So you can see our two fans plotted in there would fit within that range. We could add more fans and cycle them, but we have two plotted here. If you go over to the efficiency chart on the right again, we have the same dashed lines for our range of efficiencies between 0.05 and 0.1. And you can see, obviously, something that strikes your eye is the yellow line at the top, where if you follow the 0.05 line up across, we're at about 45 CFM per watt at that 45 hertz on this 36-inch fan. So that's a much higher rate than at that black line, which is less than 20 CFM per watt. So more than double the CFM per watt. So the other thing that we notice on this chart is that as you follow the blue line on the left-hand side, the blue line stays a little bit more horizontal than what the black line does, which ends up dropping off. So we can see with the 36-inch fan, that smaller size, it does really good as we increase static pressures as well. So as we go on to the 54-inch fan, I also have two plotted here. We have the same frequency lines for the variable speed portion, and we have the same dashed line, which is a standard 54 line for two of them. And you can see the same trend with that blue line that's well above the dashed black at the top end. And if you go over to the right-hand side and follow the blue and the dashed black, you can see that there's not much of a difference in the efficiency in CFM per watt, even though with the VFans, you're outputting a lot more CFM for every fan. So that implies back to what Trey was saying about the potential in tunnel, if you use VFans, of not needing as many. You can see just in 2 here, you're jumping from, at 0 static, you're jumping from just over 60,000 CFM up to almost 70,000 CFM. So it's about 5,000 or so CFM per fan at that static. You can also see one thing from an application standpoint. At lower speeds on the 54-inch fan, if you look on the left-hand chart, the yellow line, you can see that that yellow line, we must be a little careful when applying the 54 with the larger diameter. It is more susceptible at low speeds to a drop-off in static, so it is something to be aware of at the lowest 25 hertz. But you can see even moving up to that gray line at 30 hertz, it's much better under static. And then if you go over to the right-hand side, you can see that yellow line is up almost at 55 CFM per watt, just a really high performing. But there again, the yellow line does drop off fairly rapid, but the gray line does not. So being aware of what static pressure you're actually running in min vent rate might dictate how low of a speed you go. So some of the criteria that we need to evaluate to select the proper fans are animal barn considerations. Stocking density has a huge impact just based on a difference in minimum ventilation rates of how many fans you would have linked to that min vent stage. Barn considerations, animal set points, temperature set points have huge implications, as we'll see when we get into the simulation. Just a little bit of adjustment in where you're maintaining those temperatures will dictate what stage of ventilation you're in at different times throughout the year, which has a big impact on your payback. So it is something to consider when we're selecting fans and the quantities. I have static pressure here. As you saw, the 36-inch fan did really well under static. The 54-inch does really well under static as long as you're above 30 hertz, but it is something to be aware of as you get larger with the fans, reduced speed. Static pressure impacts it more. And then the other thing, we're talking today about a broiler barn specifically when we're looking at the simulations that we did. But when we get into pullets and we get into breeders and some of these aviary barns with light traps, being aware of the additional static pressure requirements of your fans will change the payback, will change the efficiency a lot. So when we're applying these fans, static pressure, something we need to be aware of. Also, we can conceivably program these VFans and use them in a variety of different ways, but we do have to be aware of the controller capabilities because we have to be able to actually control them in the way we intend to. So controller capabilities would be something to consider, especially in retrofit where you have an existing controller that you're not selecting. But this leads us to the quantity of fans and the actual payback of those fans. We have questions like, okay, how many fans should I use based on my geographic area? I'm in a hot climate. Does it really pay back to have variable speed fans? I'm not in the lower stages of ventilation that much. So these are some of the questions that come up. We look at Minnesota, Pennsylvania, Georgia, and then some of the international guys that are on, something like the Philippines with a minimum temperature of 65 degrees Fahrenheit. It's like, okay, do these pay back? So these are some of the questions that we should be asking, and in order to answer those, we really need to look at each individual case because there is a difference. So that brought us to really evaluating these different geographic areas and creating a tool that would allow us to do that. So we have a ventilation simulation. The plot here is for Middletown, Pennsylvania, a year's worth of hourly weather data. So you can see the min, max temperatures, and you can see towards the middle of the graph would be around summer here, which would be much hotter, and you can see the blue line trend in that way. We're accounting for geographic differences and climate differences, and then we're evaluating heat flow through the barn, R values, other equipment in it. We're evaluating the sensible heat load of these animals. In this case, we'll be looking at a broiler house, and even as the temperature increases in the barn, the sensible output changes. So how does that impact it? If we're adding supplemental heat, if we're adding evaporative cooling, and then even in the barn status, we have different age ranges that we're growing birds to. How does that impact it? And then static pressure, as we saw in the charts. Static pressure impacts the performance of the fans, controller set points, things like that. So here we have simulation results for a 40 by 500 broiler barn. We started with about 28,000 with about a 5% mortality rate, and we were growing a 45-day broiler. So you can see the declining red lines, that's the set point. You can see if you count up those declines that we have a little over 6 turns in this simulation in this year. The light green is how we did at maintaining the inside temperature to that set point. So you can see at the beginning, we followed the red line very well, but towards the middle, then we were in higher stages of ventilation. So we were offset above it as the temperature outside increased. You can also see where the blue line, which is outside temperature, goes above the green. That would be evaporative cooling must have kicked in there. So what comes out of this? Well, the simulation results here again for Middletown, we have 0 stage, which is our min vent stage. The whole way down then stages 1 through 12 are cooling stages. So what's notable here, if you look at the red, is the percent runtime. In min vent for Middletown, we ran about 28% of the time. So if we skim down that column though, down to stage 12, we see that stage 12, we were at 9.2% runtime in the highest stage of cooling. But what's really notable, especially when we think about hot climates, if you go over to the actual percentage of electric cost, across from that 27.5 that we looked at, our electrical cost in min-vent was only like a little less than 10% of the total electric costs, whereas you go down to stage 12 and it's a whopping 36% of the cost. So this has an impact as we think about VFans and the number of VFans and how climate impacts that. So in this simulation today, when we think about return on the investment for different quantities and then also long-term savings, we're looking at 4 different geographic areas: Minnesota, Pennsylvania, Georgia, and then Philippines. You can see the electrical cost column in kilowatt hours, which is what we would expect. Minnesota is the least. We're in full ventilation, a lot less. And then the whole way down to the Philippines, which is in full ventilation quite a bit. And you can see that by the next 2 columns, which is the percent runtime. So you can see the columns of minimum ventilation, Minnesota 41%, Pennsylvania 28%, which is what we looked at in the previous, down to 14% in the Philippines. And you can see the inverse in full ventilation then, where we start at 3% and go to 44%. But there again, when we go to the percent of actual electric cost, the big outlier there is in the Philippines, full ventilation, 67% of your cost in electric. So these are some things that we have to consider when we're evaluating quantities. So for the simulation that we're going to discuss now and some of the results, we started with an original fan configuration of 4 36-inch standard fans and 10 54-inch standard fans. And this is the Middletown case that we've been talking about, where we had about 25 or 24,000 kilowatt hours in electric, but the equipment cost was 14,000. So we tried 5 different scenarios. The first option was just to replace all of the existing standard fans with VFans. Option 2 was to switch out the 436s with 236s for a 54, and then you can imagine a 54 in the front end of the barn in min vent, and then one in the back end of the barn, and then the other 10 fans would have replaced the standard 54s for full. Option 3 then is a combination of 6 54-inch standard fans versus 5 54-inch V fans. And then we just alternate in option 4, fewer 54-inch standard fans at 4 and 7 54-inch V fans. And then the last one was 8 54-inch standard fans and 3 V fans. So then when we look at the actual return on investment, we can see a different ROI for these different scenarios, ranging from 8 years. And if you look at the equipment cost, replacing all V fans has a much higher equipment cost. But you can see in the green, I've highlighted the least ROI and the greatest 10-year savings. So you can see in this scenario in Middletown, it would appear the greatest payback would be less than 2 years on 3 V fans and 8 54-inch fans. And you can see that the greatest 10-year payback is just under $5,000 in this scenario. So then to answer some of the questions of how do different geographic areas relate to this, we'll run some different scenarios. So this is Minnesota. So I ran the same set points, the same size barn. So everything is the same except just changing the outside weather data. And we have the same 5 options. And we can see that the ROI, the best one, is still just over 2 years payback, and over $4,000 savings on 10 years. So going to Minnesota, the fewer V fans still seem to pay back the fastest on this broiler barn. But as we go to a hotter climate is where we have a decision to make. You would expect option 5 still to have the best ROI just because the equipment cost is the least. But now you have a decision to make because the greatest 10-year savings is no longer option 5, but the greatest savings is option 2 with 11 V fans. So we see it as the hotter climate goes, there's the return on investment that's your initial investment, but then we have to be thinking ahead a little bit about the actual long-term savings potential as well when we're making decisions on the number of V fans. So you can see here, we have less than a 4-year return on investment in option 2, but almost $8,000 potential savings in electric over 10 years. When we go to the Philippines then, we still expect the ROI to be for the least expensive, but what we see there on option 2 with all variable speed fans is a considerable increase in 10-year savings, up over $14,000 potential there. One thing to consider too, all of the electrical savings that I've simulated here is at 10 cents a kilowatt hour, which is, I think, a fair average across the United States. But when we think about the Philippines, we actually have 22 cents per kilowatt hour. So now when we look at a hot climate and we look at the potential 10-year electrical savings, it is a huge potential for savings by having all variable speed fans. Really great return on investment. Even option 2, which is the greatest 10-year savings, is just over 1 year return on that investment for that initial cost of the equipment. So just phenomenal savings potential there, and almost $40,000 10-year savings. So really great option even for hot climates, which is maybe not what everybody would always think for the variable speed fans. So for a payback summary, for cold climates, and this remembers specifically broiler houses, which is what we're analyzing here, it will change based on a lot of the parameters we already talked about. But for this broiler simulation, cold climate, 25% VFans is probably the best ROI and savings option. As you get into a little hotter, mild climates, little hotter climates, probably around 50% variable speed fans might be the best combination of your return on investment and your long-term savings. But for hot climate, 100% VFans has significant potential. And then the other thing to note is there are pockets even in Iowa of 14 cents per kilowatt hour. So considering that electrical cost and even forward thinking of where electrical costs might be in the future might sway you from looking at the lowest return on the investment versus the potential long-term savings. So with that, we will get a little more in-depth look at the variable speed fan with Doug Berkey in our training barn in Coldwater, Ohio.
Thank you, Ben. Welcome, everybody. Good morning. Glad everyone is taking part of this. We believe this will really be good information for you on new VFans from Valco. And as we're here in our training barn here in Coldwater, we do have a 54-inch VFan installed here, as you see. And one thing on this is the VFans, they still install just like all our other standard fans. They mount inside the framework you have. There's nothing different about them, how they mount, so that's very good. It keeps everything common. And as you see, we have the black fiberglass here, and that's good for if you're trying to get dark out scenarios in your barns. And with this fan, you can see where, as Trey had discussed earlier, it's direct drive, so it saves a lot on maintenance. When you don't have to replace a belt, you don't have belts wearing out, you don't have extra bearings that you have to keep greasing all the time. And with the direct drive, with the motor itself, you actually have a larger shaft than normally. Given that larger shaft, it gives more stability, more robustness to the design, and also gives larger bearings, which are also stronger for the fan themselves, for the motor. So that's a big plus there. Everything is more robust. With the location of this VFD, the variable frequency drive, as discussed earlier, people may like to put those on the sidewalls, but it's best right here because the airflow with the fan, it's keeping the drive cool. It's going to help prevent any issues that may occur if it's starting to overheat or anything like that. There are heat sink vanes in the back of it. Again, that keeps the air keeps the dust off of them, which helps dissipate the heat from this. So it's a good location, good design to have this right here. Also, when they come shipped, assembled, and everything, the VFD is pre-wired to the motor, so you do not have to worry about connecting those wires. It's already performed for you when you receive it. Another aspect with these that you want is, as discussed earlier, to kind of save money and cost savings during installation, is you have your main power coming into the unit. You can have this a main line supplying multiple fans. Just so you have one main line coming from your house control, then you can tie off of that to multiple fans. So that way you do not have to run several main high power lines to each fan from your control. So that will save you a lot of money. Again, the flow of everything on here is done very well. Again, robustness. You can see where we have a cast aluminum blade on this unit as well. And it's a good, strong fan. As Ben showed earlier, very efficient, very well designed. If anyone has any questions, I think we're going to open up to the question section. Thank you.
Thanks, Doug. It's kind of neat to see, looking through the calculations that we're showing a pretty conservative estimate on what we have, but we're showing a less than 2-year ROI, and that's not even taking into account, rebates or installation or the preventative maintenance that doesn't need to be done to these as compared to a standard on-off fan. So thank you everyone for sharing that with us. To open it up to the questions, we've got some questions coming in. If anyone has any further questions, again, down at the bottom of your screen, if you wiggle your mouse, it'll show up down at the bottom for your chat function. Click on that and feel free to type in a message to Kayla. who is hosting this in the back end, and she's going to send those our way so that we can get all of your questions answered. And if we miss any, we'll certainly send out an email afterwards covering that too. Some of the questions that came in, that you guys decide who's going to answer it, is that I just mentioned it, but you mentioned it earlier, Trey, the rebates. Can you elaborate a little bit or have any specifics on what that is or where somebody would find one of those?
Yes, Sean, that's a great question. Let me pull up a website real quick. Your local energy provider. What I did was I clicked up my local energy provider, which is Clark County REMC, went to their website, was able to pull up rebates, and it talks about, you know, different lighting, different motor rebates, so you could actually be able to go there and see. And then also you could go to the USDA website for your local area and be able to walk through that as well. And also you could go to your local USDA office, and they will be glad to help you with that as well.
Okay. I didn't actually see your screen come up there, Trey, but I think we got the gist of what you were talking about.
Yeah, it was some technical difficulty on my end, but yeah.
No worries. Another question that did come up, looking at the lifespan, how would you say the lifespan of a VFan or a variable speed fan compares to a traditional fan?
Well, and that's also a very good question, Sean. With the lower maintenance repair costs that we've already discussed, and then the points that Doug pointed out there in the training barn as well, with the motor being able to actually stay cooler versus your typical on-off fan, then we feel very confident that this fan will actually last longer than your standard on-off fan. So yes, you will get a long lifespan out of this fan.
A question I had here was for our timer fans, and I don't know if this is a Ben or a Trey one, but if you're using a variable speed fan as opposed to a timer fan, does it negate using it as a timer fan, or would you recommend that people don't set them on timers and only run them based on the variable speed?
You can run a variable speed fan as a ramping variable speed fan, but what we find is that in your best energy savings mode, you would still potentially cycle two larger fans at lower frequencies because you'd actually have your highest efficiency gain there. So you can do it either way, but there is some advantage to actually still using a timer fan, a variable speed fan as a timer fan running at a lower frequency, maybe 254s is what we were looking at, because of that really high CFM per watt at that lower speed. So it's really a matter of looking at whether you have real nice airflow lines, like Trey was commenting, that's achievable with variable speed fans, versus if your greatest concern is energy efficiency and electrical savings.
Thank you. Yeah, I could see it also come into play a little bit, maybe with like your inlet management, depending on you know what sort of airspeed you're looking to get into, so that you don't have to radically redesign how you're opening and closing your inlets during brood. Another question that popped in: are these simulations, Ben, that you were sharing with us? Was that based on a specific fan? Was it a fiberglass fan? Was it a galvanized fan? Does it matter tremendously based for your simulation?
Great question. These were galvanized fans. So all of them were galvanized fans. It was replacing the 36-inch fans were galvanized fans on off versus the variable speed. The 54s, it was replacing 10 damper fans with a variable speed galvanized fan. It will change, and each consideration, each case needs considered, because you have a vast array of actual energy efficiency of fans. So each fan is going to have a different simulation result.
Okay, thank you. Another question was on the control of the fans and how exactly the VFD is working. So what's the signal that the controller needs to be able to manage to say that, yeah, this controller could work or this controller wouldn't work?
It's a 0 to 10 volt output from the controller. So you'd run signal wires from your controller to the VFD, and then you can vary the speed based on that 0 to 10 volt. So you can save. Trey had alluded to saving on on the cost of wiring runs. So to elaborate a little bit more, from your controller, you can run signal wires to your fans, and you can actually have all of your power even at the fan end coming in, and now your power wires can run separate to your fans. So you save those larger cables from an installation and also the cost of them.
Yeah, so whereas with your on-off fans, you're running the actual L1 or L2 out to that fan as a high voltage line. Here we're just running a 0 to 10 volt signal, and we can bank the power off of one, larger power going back to all of them. Okay. Hang on, just checking what's coming in on the chats here. Can the VFan ship knocked down? This must be an international question. Can the VFan ship knocked down for shipping efficiency? I know that one, but I'll jump on that one. Yes, they do. When you're talking about the galvanized, especially, fiberglass housings obviously are made in large pieces and don't ship quite as nicely, but the galvanized does ship knockdown, not as far down as a standard on-off fan would go, because we do pre-wire that VFD and the motor together, and to keep those safe in shipping, they come mounted onto the struts in the frame, so it takes up a little more room than a standard on-off fan would, but it is a knockdown version. For your colder climate simulation, Mr. Carvel, why did we not have a combination of 236s and 354s as an option? Why were we looking at not just going with more smaller fans in the cold climate as opposed to just going straight to the 54s?
Time. I just didn't run every combination of simulations possible. So, and I actually didn't start with Minnesota. I started with some hotter climates, and then kind of went back. So I never actually dropped out the fans. So each geographic area, you would trial different combinations of those fans to get the best ROI. So I just tried to keep the same combination throughout all 4 locations. So there are certainly potentials of greater paybacks in the different geographic areas than what I even had shown.
Pretty interesting stuff. But I guess the basic takeaway would be that, for any area that you're thinking, man, I want to be able to find the best and fine tune this, send in, talk to your distributor, talk to your Valco territory rep, and send in exactly what you're thinking about. And we can probably run those ones on a case by case basis for you.
Yep.
All right. It is 10:46. We've run a minute over, but in respect to your time, we're going to let everybody go. I do want to thank our presenters, Trey and Doug and Ben, and all the people on the back end that have made this possible, and you for attending. This was recorded. We will, within the next week, send out a link to everybody to your registered email addresses, sharing the recording so you can look at it again at your leisure. And if you have any questions or any concerns in the meantime, feel free to reach out to us through the website, through your local rep, or give us a call. Thank you, everybody, and have a good day.